Hello, my name is Francesco Demisa, and this is my 21 Sticks program. So in this one, it is going to be a Java program which executes a game of 21 Sticks. This is a game with several variations, but it's essentially just a very simple version of pick up sticks. There are two options where one would be able to play against a computer or for two people to play against each other. So in either case, the game will randomly choose who goes first, and the person can pick up either 1, 2, or 3 sticks on every turn. And so after you pick up your sticks, then the next person will go pick up their sticks, and it will go down until there's 1 stick left. Now, the person who would pick up the last stick would be the loser of the game. In addition to this, the program will not allow for a person to lose if they have a winning move, so they can't take more sticks than are left. So if there's 1 stick, they can't take 2 sticks, and etc. And they cannot take the last stick purposefully. Okay. So in the main function, something notable here at the beginning is that it has throws exception. And the purpose of this is for later on when I want to do this command right here, which will allow for a short pause in between each of these print statements, right? Okay, so other things we have is a scanner for input, a bunch of variables such as names, replay, the amount of sticks, and whom, which is going to be determining who is actually moving. So as I said before, in this little wall of text, it's going to be presenting an introduction to the game and the instructions for the game. And there's going to be a short pause in between each line just so the person can read it in time. And then it's going to call the do this function, which is going to have the next part of the program. Now, the reason that I separated it in this way is because this program allows for the player to replay the game. And if you're replaying the game, you may not want to see the instructions every single time, especially with the pauses. It can take a little bit of a long time. So this just allows for, if you're replaying the game, to skip the instructions and get right to playing. And so, like I said, it's going to call the do this function, which is right here. And what this is going to do, it is going to choose if, this is going to be where the player either chooses if it's 1 person against a computer or 2 people against each other. It's going to be asking for the players' names and then determining the winner as well. So in other functions later on, it's going to be returning the winner value, and whoever's the winner is going to determine is going to print out a victory message in accordance with whoever won. And then it's also going to have the replay function so that if you want to replay it, it'll just run this function again. And if you don't, it'll just exit the program. And so once you actually enter whether you're going to play as 1 player or 2 players and then put in the names and all that, it's going to call the next function. So in the case of if you choose as 1 player and you're playing against a computer, it'll go to this versus CPU. And here it's going to, well, first thing it's going to do is determine who goes first. And it does this basically in a sort of binary fashion with a random number generator and determining if it's above or below 0.5. And this is a little bit interesting here, where if the computer goes first, it's going to have the computer take a random amount of sticks between 1 and 3, and then it's going to run another function which is going to allow for a back and forth game. But if by chance the player is randomly selected to go first, no matter what, the computer will always win. This is essentially where just the computer would play a perfect game against you, and this is only possible for the first player to win. So the reason for this is that mathematically the way that 21 sticks works is that no matter what, the person who goes first will lose every single time. And the way to ensure this is that you have to take, so say there's 3 sticks. So say the maximum that a person can take in a turn is 3 sticks. If you take 3 sticks, the other person, the person who would go second, needs to take the remainder of however many sticks are possible to take plus 1, so in this case 4. So you would only take 1 stick because you want the amount of sticks that your opponent took and your own and the amount of sticks that you took to equal to 1 greater than the amount of sticks. Mathematically, this will go down, and eventually the person who goes second will win no matter what. So if you go first, you take 2 sticks, the other person would take 2 sticks in the situation where you can take a maximum of 3 sticks. That's exactly what the computer will do. It will see how many sticks you take, subtract that number from 4, and then take however many sticks remain, and it will eventually win no matter what. So I guess if you're playing a computer, you better hope that you don't go first, or else you will definitely lose. In addition to this, this is the code that won't let you input something that is less than the actual amount of sticks so that you can't purposefully lose. Now, I'm going to skip this for now and go down to this because this is related to the program where you're going against the computer. This one, vcomp, is where this is if the computer makes the first move. So the reason that it's not automatically winning is because the player can mess up, and so it just has to be done in this way. And what this is determining is that while the winner is 0, so there's no winner, and then it checks who is actually going. So if whom is 2, that means that it's the computer's turn. If whom is 1, that means it's the player's turn. Back here in versus CPU, you could see that after after the computer goes first, it would set whom equal to 1 so that the player would go first even though the computer's function actually shows up first. So it will ask you how many sticks you want to take, it'll take the other amount of sticks, and then it'll also do the same thing with the invalid input. If by chance it's near the end of the game and after you take however many sticks you're going to take, the amount of sticks equals to 1, then you would be considered the winner, because no matter what, the computer would have to take the last stick. And for the computer, it's going to take from an array of numbers 1 to 3 of which value it's going to take, and that's going to equal the amount of sticks it's going to take. So it's essentially randomly choosing from 3 how many sticks it's going to take. So if the computer goes first, it's anyone's game. As long as if you play a perfect game, then you will win for sure. If you don't, then it's anyone's game essentially, because the computer will not mess up. Once there are 4 sticks or less, it will take however many sticks are left to win, and it will win. So try not to mess up. So going back, we have the versus humans. This is a little bit more simple because it's just 2 people playing against each other. There's no need to figure out any kind of formula for a guaranteed win. So in this one, it's going to have the 2 players going against each other, name 1, name 2. It's going to be doing the same type of random selection for whoever goes first. In this case, it's just going to ask the first person to take however many sticks. Then it's going to go over to the VP function, which is pretty similar to the vcomp function, but instead of having a random selection for the computer to be taking sticks, it just has another one of the regular prompts, but while whom equals 2 instead. And in any of these, it's going to end up returning the winner, which is going to go back all the way up to here, where it's going to read who actually won. So like if the winner is 1, 2, or 3. And the way the winners work is that 1 is always set to the computer, 2 is always set to name 1, and 3 is always set to name 2. Because as you might have noticed, I reused the variable name1 for both the versus computer and the versus people function, and that's perfectly fine because it's not like it's gonna, if you replay it, it's gonna like transfer the name over or anything. No, it's gonna start completely over, and all the names will be reset once you input them again. So we can actually run the code here. I can try a couple different variations. So like maybe I'll play the computer first, or maybe I'll play a human first. We'll see. As you can see, there's going to be a slight pause in between each, so it's not actually going to be coming out exactly. So let's just say I'm playing the computer first. I'm going to call myself Frankie. Okay, unfortunately, it looks like I am going first, so no matter what happens, no matter how many sticks I take or however I may try to play the game, the computer is going to beat me no matter what. So as you can see, I took 3 sticks and he took 1 stick. If I take 1 stick, it should take 3 sticks. So there, it took 3 sticks. This is not looking good for me. I'll take another 3 sticks. There are 9 sticks left. I probably would want to get to 5, but it's just not possible for me. 5 sticks left. Yeah, if I take 1 more stick, there would be 4 sticks left. He just takes 3, and I lose. If I take 3, it'll just be. If I take 2, it'll just be 3. He'll just take 2 more sticks. So I'll just take 3 or something like that. And so he took 1 more stick. 1 stick remains. So the computer wins. And I'm going to play again. This time I think I'll try 2 players. So let's just go Frankie again. Or maybe I'll go with a different name just to show this works. I'll go Momo. And then I'll go Overlord. How about that? Battle between Momo and Overlord. Okay, so let's say Overlord is going to go first, so if I were to play a perfect game, no matter what, he would win if I used the strategy. But let's just mess up a little bit. Okay, so now there's 16 sticks left. Now it could be anyone's game. Well, let's go 2 sticks. Let's go another 3. Overlord will take 2 sticks. 5 sticks remain. Now, unless Overlord messes up here, he should win 100% because, as we saw before, no matter how many sticks I take, then I can bring it down to 1 stick. And as we can see, Overlord won. I'll just exit out. I'll say, no, I do not want to replay. And there we go. The code has ended. And that is 21 sticks.